Hello everybody, this is Philipp Jonas for Kalamazoo Valley Community College, and today we're going to talk about measuring the cost of living. In our previous lecture, we already learned a first measure of the price level in our economy, the GDP Deflator. But the GDP Deflator is based on the cost of everything that was produced in our economy. More commonly, when we measure price levels, our primary concern is the so-called cost of living, or the cost of those things that were consumed in our economy. This is where the Consumer Price Index comes in. So similar to the GDP deflator, we're going to be measuring an overall price index reflecting a bundle of goods, but the bundle is constructed differently. It is often referred to as the basket, as in our nation's shopping basket. And this one is based on a regular survey of consumers conducted by the Bureau of Labor Statistics. Once this basket of representative consumer goods is fixed, the Bureau of Labor Statistics then hires census employees to measure the prices of these items every month across our country. Put together, this allows us to compute how much it would cost a typical household to buy this entire shopping basket. Now, if you've already taken a course in statistics, you know that we will actually want to weight the prices of the individual items in this basket because some of them will be bought more frequently than others. Otherwise, the price of a big ticket item, like for example a car, would completely swamp the price of a more commonly bought item that has a lower individual price, like let's say a pound of ground beef. However, this is not a statistics course, so we're not going to be engaging in weighting ourselves. Instead, we will simply add together the prices of the items. Once the cost of this basket is then computed, we can transform it into the Consumer Price Index. Take the cost of the basket in the year where it was measured, divide it by the cost of that same basket in a chosen base year, and multiply by the number 100. If you look at this formula closely, you'll recognize it as very similar to the formula for the GDP deflator. That's because both of them are index numbers, constructed by taking a number in the current year, dividing it by that same number in the base year, and multiplying by the number 100. The difference is which items go into the bundle of products. With the GDP deflator, it's nominal GDP divided by real GDP. So the bundle of items is everything produced in our country. With the Consumer Price Index, on the other hand, we are taking a look at the cost of this representative bundle of consumer goods. The result of this calculation is what's called the Consumer Price Index. But typically when you hear about the Consumer Price Index in the news, you'll hear about it as a rate of inflation. As we learned in our previous lecture, a rate of inflation is the percentage change in this index number since last year. So using the Consumer Price Index as an example here, you take the Consumer Price Index this month, subtract the Consumer Price Index from the same month last year, and divide by last year's Consumer Price Index. The resulting decimal you then convert into a percentage, which some of you may have learned as being done by multiplying by the number 100%. So this is the idea of the Consumer Price Index. Now let's go ahead and work through a simple example. We'll return to our economy that produces nothing but pizzas and lattes. So we've got a similar set of prices here from our last lecture, but this time around, instead of looking at the production quantities of our economy in each of these years, we instead have the Bureau of Labor Statistics survey the consumers in our economy. And they determine that a typical household buys 4 pizzas and 10 lattes. So the first thing we want to do is establish the prices of these items using the Bureau of Labor Statistics. And here you can see these prices for each of the 3 years. Armed with that information, we can then calculate the cost of this basket. So that's the quantities in the basket times the price in each of these years. For example, in 2020, we have 4 pizzas being bought for $10 each, plus 10 lattes for $2 each. That means a consumer would have to spend $60 to buy the entirety of the basket. Then we track the cost of this basket year after year. So in 2021, the pizza is up to $11, the latte up to $2.50. That means the price of the latte is now of the basket is now $69. And in 2022, with the prices being up to $12 and $3, the price of the basket rises to $78. These numbers, $60, $69, and $78, are the cost of the basket. They are not yet the consumer price index. In order to calculate the consumer price index, we have to take these basket costs and transform them into an index number. That means we have to choose a base year. You know that I like to take the top row of any given table as the base year, so we'll use 2020 here. But when you're solving a problem yourself, pay careful attention to which year you're supposed to be using as the base year. Any year is possible. So let's go ahead and calculate the consumer price index for 2020. As always, when working out an index number, in the base year, it will be equal to 100. That's because in the base year, the price of the basket in the current year and in the base year is the same number. 60 divided by 60 times 100. The consumer price index in 2020 is the number 100. Simply 100. No units, no percent, it's an index number. Let's go ahead to 2021 now, where those prices have gone up. So the index number is going to go up. We take the price of the basket in the current year, 2021, that's 69, divide by the base year price of 60, 69 divided by 60, times 100, gives us the number 115. So you can probably already tell that the rate of inflation, the rate of increase in the consumer price index here was 15%. But let's do this one more time for 2022. $12 pizzas, $3 lattes mean the cost of the basket has risen to $78. Take the $78 price divided by the base year, 60. Always go all the way back to the base year, 60. And that means in 2022, the consumer price index is now 130. Those three numbers, 100, 115, 130, those are what's referred to as the consumer price index. To go from the consumer price index to the rate of inflation, we work out the year-over-year percentage increase in that number. So going from 2020 to 2021, that's of course a 15% increase. 15-point increase divided by 100-point base times 100%. And let's do it again for 2021 to 2022. Again, the index number increases by 15 points. But of course now, the first of those two numbers we're dividing by is 115. So 15 points divided by 115, that gives us a slightly smaller percentage. The rate of inflation in that second year would have been about 13%. On this slide, you can then see every step of the calculation from the basket to the rate of inflation. So if you would like, go ahead and pause the video, go through these steps one more time, and make sure you can carry out everything that's displayed here. Now let's go ahead and work an example. So again, we have an economy, and in this economy, two products, beef and chicken. They go from $4 each in 2020 to $5 each in 2021. And then in 2022, beef goes to $9, chicken goes to $6. So their relative price is changing. We'll talk about that a little bit more down the line. So we survey our consumers and determine that the representative household buys 10 pounds of beef, 20 pounds of chicken. That means, for example, that in 2020, which we'll use as the base year for this exercise, the cost of the basket is $120. 10 times 4 plus 20 times 4. Based on this information, do the following. For 2021, calculate the consumer price index and then from 2021 to 2022, calculate the rate of inflation. As always, go ahead and pause the video if you would like to give this a shot yourself. Alright, let's go ahead and compare our answers then. First, the consumer price index in 2021. We have to first calculate the cost of the basket in 2021. 10 pounds beef at $5 each, plus 20 pounds chicken at $5 each is $150. That's the cost of the basket. Now to transform this into a consumer price index, take the price of the basket, divide it by the price of the basket in the base year, that was 120, so 150 divided by 120 times 100. In 2021, the consumer price index is 125. And since it is of course 100 in the base year 2020, that means from 2020 to 2021, we had a 25% rate of inflation. Let's calculate that other rate of inflation as well, going from 2021 to 2022. First, let's work out the cost of that CPI basket in 2022. $9 beef times 10 units plus $6 chicken times 20 units means in 2022 our household is spending $210. So if we compare that to the cost of the basket in 2020, that was $120, $210 divided by $120 times 100 means the consumer price index in 2022 is 175. Finally, let's convert that into a rate of inflation. In 2021, the consumer price index was 125. In 2022, it's 175. So the index has increased 50 points. Dividing that by the first of the two numbers, 50 divided by 125, means the consumer price index has increased by 40%. That's our rate of inflation. Now a handy side note here, if all you're after is the rate of inflation, you don't actually have to calculate the consumer price index first. You can also just look at the increase in the cost of the basket. So a little reminder here, the cost of the basket in 2021 was $150, in 2022 was $210. If you would like, convince yourself, going from $150 to $210 is also a 40% increase. So that was our first example of how to work out the consumer price index. As always, when we talk about such macroeconomic data, I want to give you a bit of a feel for what they look like in real life as well. So here are the components that go into what the typical household buys every month in the United States. And first thing you might notice here is the largest component is housing. That's your rent or your imputed rental value, but also utilities and such. If you compare to your own budget, you'll probably also find that housing is the biggest category. But perhaps what I want you to remember the most is that if you put the top three together, housing, transport, and food, they account for about 3/4 of the typical household spending. And since we calculate our rate of inflation from this basket of spending, that means about 3/4 of the rate of inflation is determined by changes or lack thereof in the prices of housing, transportation, and food and beverages. Those are really the big ticket items. Everything else the typical household spends money on is going into that remaining about 1/4 slice of spending. This of course also means when we talk about inflation, we're talking about it from the perspective of the average household. Now, households might have a different pie chart depending on where they are in their life. For example, if you're retired, your expenditure slice for medical care might be bigger. Expenditure slice for education and food might be lower. That means the official rate of inflation might not fully capture what your individual life situation is like. But that's not the only thing you have to keep in mind when it comes to the official rate of inflation. It also has some well-known weaknesses that result directly from how it is tracked. We've got a basket of goods and services, and we track the price of this basket year after year. Well, there's a couple of well-understood problems with that. Let me return to our previous exercise with the beef and the chicken to illustrate the first version of this problem, which is called substitution bias. So again, we've got our economy from 2020 to 2022 with beef and chicken. And here, as a reminder, is the cost of the CPI basket in each of those years, 120, 150, and 210. So this CPI basket was calculated using 10 pounds of beef and 20 pounds of chicken. So for example, in 2021, 10 times $5 beef plus 20 times $5 chicken means $150 CPI basket cost. But look at how the price of beef and chicken evolves. From 2020 to 2021, both beef and chicken get 25% more expensive. But from 2021 to 2022, beef rises much faster, about 44% in price, versus chicken, which rises about 20% in price. This happens all the time in real life. All the products in our life don't all increase in price at the same rate. Some things increase faster, some slower, some things fall in price. And of course, households adjust their behavior when these relative prices change. So this CPI basket that was established in 2020, in this example, 10 pounds beef, 20 pounds chicken, that might be relevant for 2020 and probably for 2021, since those prices went up equally. But in 2022, you'd really expect households to cut back a little bit on beef and perhaps add a little chicken to make up for that. So let's say, for the sake of this example, that what households actually buy in 2022 is 5 pounds beef and 25 pounds chicken. So what that means is we now have a mismatch. The basket we're tracking, 10 and 20, is no longer what the households are actually buying, 5 and 25. Let's see what happens as a consequence. Two things I want you to work out. First, figure out what the household is actually spending on beef and chicken in 2022. So if they continue to buy the CPI basket, they'd be spending $210. But they're not buying the CPI basket anymore. They're buying 5 and 25 now. So figure out what it costs them to buy that. And then based on that information, figure out the rate of inflation from 2021 to 2022. And go ahead and use the shortcut method here. You don't have to work out the consumer price index first. You can work out the rate of inflation by looking for the percentage increase from the cost of the CPI basket in 2021, the $150, to whatever your answer to A is, what the household is actually spending on beef and chicken in 2022. Go ahead and pause the video if you'd like to give this a shot. All right, let's go ahead and compare our answers here. So first, what's the household actually spending in 2022? They are buying 5 pounds beef at $9 each, that's $45, plus 25 pounds chicken at $6 each, that's another $150. So $195 is the cost of the basket in 2022. You can already see where this is going. The official cost of the basket rose to $210. What the household is actually buying rose to $195. So our official measure of the price increase is going to be too large in some sense here. All right, so let's have a look at what that rate of inflation looks like. Going from 2021 to 2022, the household increased its spending from $150 to $195. That's a 30% increase. But the official rate of inflation will have been calculated by looking at the increase from $150 to $210. The official rates calculate as if the household's always buying the same things. That's a 40% increase. So what the official number is showing, cost of living is going up 40%, is actually overstating what's happening to our household. The household's actual expenditures are going up by 30%. So in that sense, the consumer price index has a habit of overshooting increases in the cost of living. That's because households, of course, always switch their spending in the intelligent direction, trying to save some money. This is called substitution bias. And it's not the only one of the bigger problems with the consumer price index, but the other two work in the same fashion. The consumer price index is calculated by having a fixed bundle of products that we track year after year, while actual households switch what they buy, not just year after year, month after month. Think of yourself. When you go to the store every week or two, do you always buy exactly the same thing, or will prices influence what you buy? Of course they will. If something is on sale, you might switch towards the on sale item, away from some other things. So where else does this show up but in substitution? It also shows up with the introduction of new goods. That's because when the basket's established, we track that basket now year after year. But of course, over those new years there, new products will show up. And to the extent that households are buying them, presumably they are cheaper or better than what existed before. And finally, while when it comes to the products that are being bought, we try to track if they get better in quality, that can only be done with big noticeable changes in product quality. Often products improve in many small, just unmeasurable ways, where again, part of that price increase might actually buy you a better thing as opposed to being pure inflation. So how big are these problems with the consumer price index? I would say about 0.5 percentage point. For the typical American household, the official rate of inflation is probably about 0.5 percentage points bigger than how their cost of living is actually increasing. So if you read an official inflation rate of 2%, maybe think to yourself, okay, for the typical household, that means cost of living has gone up 1.5%. So this is the consumer price index. And most of the time, this is our preferred rate of inflation in macroeconomics. But this is not the only way we've learned to measure inflation. In our last lecture, we learned about the GDP Deflator, which instead is calculated by tracking the prices of everything produced in this country. Here's a chart showing you the rate of inflation calculated using both methods from 1970 until 2020. As always, recessions are indicated as gray bars. So first thing I want you to notice is, even though they measure inflation in different ways, because both are very broad measures of inflation, at the end of the day, you should expect them to track each other relatively closely. Also, looking historically, there are a couple of inflation rates that you should be aware of. For example, if we look at the last couple of decades, our central bank, the Federal Reserve, has gotten quite good at keeping inflation low and stable. In fact, the Federal Reserve has an inflation target for the United States. We try to have inflation at about 2% per year. We'll learn in a future lecture how you do that, how you keep the rate of inflation under control. But notice, even though we don't typically hit that target exactly, it's pretty tough to hit an inflation target exactly, we do stick pretty close to it. So if you think about the future, 2% is always a reasonable first assumption about what inflation is going to be, as long as this inflation target of the Federal Reserve stays at 2%. Secondly, if you talk to somebody who was around in the 70s, they'll probably mention that when it comes to inflation. Because in the 70s, the United States experienced 2 time periods with high rates of inflation. If measured by the Consumer Price Index, we had a couple of months that were as high as 15% year-over-year inflation rate. So if you've lived through something like that, that'll have left an impression. And then finally, if you look at 2009, something unusual happened there as well. We experienced several percentage points worth of deflation. Deflation refers to falling prices. Sounds awesome, is actually a sign that things are going terribly wrong in the economy, something else we'll learn about in a future lecture. So while the Consumer Price Index and the GDP Deflator tend to track each other pretty closely, they are not the same number. And sometimes they are many percentage points apart from each other. So you need to know exactly what gives you the differences between these two numbers so that you can use the right number to answer the sort of question you are asking. There are 3 major differences between these 2 ways of measuring inflation. And they're all based on what basket of products is being tracked. Number 1, the Consumer Price Index, we're tracking what a typical household is buying. The GDP Deflator, we're tracking what is produced in this country. One major difference, imports. Consumers buy imports, so they show up in the Consumer Price Index, but they are not produced in the US, so they don't show up in the GDP Deflator. That means when imports are changing significantly in price relative to domestically produced products, that's going to show up in the Consumer Price Index. That will not show up in the GDP Deflator. Number 2, the Consumer Price Index tracks consumer goods. Of course, there are also capital goods, goods used to produce more goods and services. Those are typically only bought by businesses, not consumers, so they don't show up in our survey. That means when the prices of capital goods change, that's not going to affect the Consumer Price Index, at least directly. Eventually, of course, that can have an impact on the price of producing consumer goods, but it will directly show up in the GDP Deflator if that capital good was produced domestically. Again, GDP Deflator tracks the prices of things produced physically inside the borders of our country. And then the most subtle difference, that's also the source of those biases in the Consumer Price Index. The Consumer Price Index is a fixed basket that we track year after year, while the GDP Deflator uses current production in our country. That means if what's being produced and consumed is undergoing rapid change, that's going to show up in the GDP Deflator first, while the Consumer Price Index has that fixed basket, so the change is not going to appear right away. Now, for the purposes of the math in our course, we'll pretend that the Consumer Price Index is always a completely fixed basket that never changes. Now, clearly that's not true. We haven't been tracking the same Consumer Price Index basket since 1928. That wouldn't be representative of our current world anymore. The products in the Consumer Price Index do get updated. We do resurvey households as to what they're actually buying. But because there are so many products in that basket, it happens on a rotating schedule, which means it can take like 5 years for a new product to show up in our CPI calculation. So to illustrate the problems that produces, we'll pretend for our course that the basket never changes. You've now learned about our 2 main ways of calculating inflation, the Consumer Price Index and the GDP Deflator. For the rest of today's lecture, let's talk about some standard applications. What can you encounter in your career where you might use a number like the Consumer Price Index in order to make some statements about inflation over time? Before we get to those, let's go through a couple of exercises where you can figure out if you know what's going to show up in the consumer price index versus the GDP deflator. Just a couple of basic stories. Number one, what if Starbucks raises the price of Frappuccinos? Real disaster there. Number two, what if Caterpillar raises the price of tractors that it makes in the US? Number three, what if Armani raises the price of jeans produced in Italy but sold in the United States? As always, pause the video if you want to give these a shot yourself. Number one, Starbucks raising the price of Frappuccinos. This shows up in the consumer price index because consumers buy it. This also shows up in the GDP deflator because they are produced inside the country. Number two, the tractor. When we survey consumers, none of them will say that they are buying an industrial tractor. But if it's produced in the US, it shows up in the GDP deflator. And finally, the imported jeans. Consumers will say that they buy those, so it shows up in the CPI, but since they are not produced in the US, they will not show up in the GDP deflator. So let's get to our first application then. And really, this is the baseline that will be what all these applications are about. Fundamentally, you use price indices so that you can compare dollar values from different points in time. If you want to compare dollar values directly, and they are years apart, maybe decades apart, your comparison wouldn't make a lot of sense because what a dollar can buy, its purchasing power, has changed over time. Let's use a popular example that's really easy to look up. The federal minimum wage. So if you Google this, in 1965, the federal minimum wage was $1.15, while in 2020, it is $7.25. This is the federal minimum wage. Many states have minimum wages at the state level that are higher than the federal number. So this might not be the minimum wage you're thinking of when I say minimum wage. But again, we're talking about the federal minimum wage here. And of course, I recognize not every job is covered by the minimum wage, so that will be for those jobs where this applies. So these $2 values. Can you now write a paper about how well off somebody would be working, let's say, 40 hours a week at the minimum wage? No, because what that $1.15 can buy in 1965, well, it's not the same as what a $1.15 could buy in 2020. So you can't simply say it's gone up 6 or 7 times. First, you have to adjust for changes in purchasing power. That's where the consumer price index comes in. We're going to take the number from back then, $1.15, and ask, what's the equivalent amount of money in 2020? How much money would you need in 2020 so that you can buy as much as $1.15 could have bought in 1965? And here's the formula for that. When you first see it, it might look a little intimidating, but it's a pretty basic setup. You take a price index today and divide it by the price index of the year you're coming from. You could even call that a base year if you will. But instead of multiplying by 100, as we do when we just want to construct an index number, we now multiply by a specific amount of dollars that we want to convert. So let's continue using the minimum wage as an example here. In our example, we're coming from 1965, and today will be 2020. Now, the number we're trying to convert is $1.15. That's the old number from the past. And in order to convert it, we need the consumer price index, January 1965, that was 31.3, and the consumer price index of today, January 2020, that's 258.8. So you can see the level of prices has gone up quite a bit. We now form a ratio. 258.8 divided by 31.3 and multiply that by the minimum wage back then, 115. The result is $9.51. Or putting that into words, to buy the same amount of things that $1.15 could buy you in 1965, you would need $9.51 today. But that's a very long sentence to say. So there's some standard language we use to express that. We would say the minimum wage in 1965 was $9.51 in today's dollars or in 2020 dollars. So in other words, we're taking time dollars as if it were a unit, as if we are converting from 1965 dollars to 2020 dollars. And now you can compare it to the current minimum wage at $7.25. You can see, corrected for inflation, that the minimum wage is currently lower at the federal level than it was in 1965. And maybe you think that's a bad deal. Maybe you think that's a good thing. Maybe you think we shouldn't have a minimum wage to begin with. That's quite okay. It's not my job to tell you what to think. But adjusting for inflation is how you think about it so that you can have a reasonable conversation to begin with. So this is something we do in economics all the time. And of course, typically we don't cherry pick one specific point in time to adjust. That could be really misleading. So in general, what we do is we take numbers across time as they existed at that point in time. That's referred to as current dollar figures or also nominal figures. And then we convert them to the same point in time, which is referred to as constant dollar figures or also real figures. We've encountered this already. It's like nominal GDP and real GDP. GDP using current dollars versus constant dollars. Well, we can do this with any dollar value using this technique. So one more time, let's have a look at this for the federal minimum wage and see how it has changed over time when corrected for inflation. So let me put up the federal minimum wage from 1965 until 2020, give us a nice time series. The blue line is current dollar, so that's the actual dollar value of the minimum wage. Notice this is a time series that looks different than what we've encountered so far. It has steps in it. That's because the federal minimum wage changes when it is updated by law. That's why you get these discrete increases in the minimum wage. And then in red, we've got that number in constant 2020 dollars. So converted for the effect of inflation, which of course means since we're using 2020 as the base year, here at the end, the numbers become equal to one another. So what's going on here? Anytime the government raises the minimum wage, like right here, it increases the purchasing power. And then for whatever time period the minimum wage is unchanged, inflation erodes that purchasing power until it's increased again. So you end up with this seesaw pattern over time. And you can also see that overall, when adjusted for inflation, the minimum wage in this country isn't as high as it used to be. In the 60s, 70s, and early 80s, it was closer to $10 to $11 when expressed in 2020 dollars. During the 80s, we didn't raise the minimum wage for quite some time, and ever since at the federal level, it's been closer to $7.50, maybe $8 in 2020 dollars. Now, that's how the minimum wage works. It's updated when a new law is passed, which means in real terms, in inflation-adjusted terms, you get the seesaw pattern. But often, we look at a dollar value in a law or a contract and we say, we don't want this seesaw pattern. We want this number to stay steady when adjusting for inflation. So what you can do is, you can take the effect of inflation and put it on autopilot, so to speak. This is referred to as indexation. When you put a dollar amount into a law or contract and you specify this dollar amount is not simply going to stay at this many dollars, instead it will increase and perhaps also decrease with some consumer price index or other price index for that matter. Anytime you find yourself in a situation where you are setting a dollar amount that will be relevant for many years into the future, ask yourself if it would make more sense for this amount to be indexed to a price index. And while this is not true for the federal minimum wage, there are some major places in our economy where you should be aware of indexation. The first one shows up in labor contracts. When labor contracts are negotiated, they are often negotiated for many years because negotiation is hard and you don't want to do that every year. The problem is, when negotiating wages in a labor contract, you know that the baseline around which you're negotiating is roughly the rate of inflation. Yes, employees will want more than the rate of inflation for their raises. The business owners are going to try to pay less than the rate of inflation in raises, but everybody knows you're roughly in the neighborhood of inflation. The problem is, you're negotiating about the future. You don't know what the rate of inflation is going to be yet. So now you're basically negotiating about two things. What's the rate of inflation going to be? And where do we want to be relative to that rate? Well, there is a very standard way of trying to break at least one of those log jams. Instead of making an assumption of what the rate of inflation is going to be, you agree that your raises are going to be relative to a COLA, C-O-L-A, cost of living allowance, a very standard acronym in labor contracts. COLA means take these dollar figures and every year increase them by the same amount as the CPI, by the official rate of inflation. And then maybe your final contract will be COLA or COLA plus 1% or COLA minus 1%, something like that. That's in labor contracts. You know what's even harder to change than a contract? A law. So many of our laws also automatically have numbers changed with the rate of inflation. Perhaps the most famous example is Social Security. Once you start collecting Social Security at a certain age, how much you get per month is based on a formula of how much money you've earned over a certain amount of your lifetime and for how long you've earned that much money. That formula gets a little tricky and is beyond the scope of this course, but look it up sometime because it'll be relevant for you. But that monthly check that's calculated, you're not going to keep receiving that same dollar figure for the rest of your life. If we did that, then year after year, the purchasing power of those Social Security checks would fall and we'd have seniors falling into poverty, which is exactly what the Social Security system is designed to prevent. So instead, once that initial Social Security payment is set, we then every year increase it with the consumer price index. And, interestingly, should the consumer price index fall, like it did in 2009, for example, we do not decrease the Social Security payments, so they only go up. This is referred to as indexation. And then finally, in today's lecture, we're going to talk about one more place where correcting for the effect of inflation is always relevant, and that's interest rates. Interest rates, whether they are for a deposit where you're earning money or for a loan where you're paying money. Interest rates always refer to money now versus money in the future. So it always makes sense to correct these for the effect of inflation. Interest rates, as you're probably familiar with them, on your student loan, a credit card, your savings account, a mortgage, those are what economists refer to as nominal interest rates. They are a percentage that tells you how quickly that deposit or debt is growing. But it's not yet corrected for inflation. A corrected for inflation number, of course, we refer to as real in economics, a real interest rate. And that one tells you not how the number of dollars in your savings account is changing. It instead tells you how what you can buy with the balance in that savings account is changing. It's telling you the purchasing power of that savings account. Now, we could do this using the formula we already discussed. Look at the future number of dollars, adjust them back to today. But it turns out, because interest and inflation rates, at least in the United States, tend to be small percentages, there is a simplification of this formula. It's one of my favorite formulas because it is so simple, that is so close to correct that we use this in a professional context as well. If you want to convert from a nominal to a real interest rate, all you have to do is subtract the rate of inflation. That's simple. Let's do one example. So let's say you've got yourself a savings account, and this thing pays 5% interest per year. So if you put $1,000 in there, for example, next year there would be $1,050 in there, 5% more. That's a nominal interest rate. It tells you how the number of dollars is growing. But what if during that time period inflation is 2%? That means since prices are 2% higher, you can't actually buy 5% more things if you leave your money in that account for a year. To figure out how much more you can buy if you wait a year to spend your money, we want to calculate a real interest rate. All you have to do is take the nominal interest rate, 5%, subtract the rate of inflation, 2%. So in this example, the real interest rate would be 3%. Or in other words, next year you'll have $1,050 in the account, but in terms of purchasing power, it's as much as if you had $1,030 today. So by saving your money for a year, you'd be able to buy 3% more things. For many economic questions, the real interest rate is more relevant than the nominal interest rate. And that concludes our lecture today on measuring the cost of living. I'll see you next time.